This is In-Ear Insights, the Trust Insights podcast. In this week's In-Ear Insights, we are gearing up for conference season. We just had last week a chat with Kathy McPhelps from the Marketing AI Institute. And one of the questions from sort of the Q&A period I thought was very interesting was, what are some of the more high level or higher complexity implementations of AI you've seen used in marketing? That from Dr. Ashley Lydiard. So Katie, in terms of this as a topic, what comes to mind for you in terms when someone asks, show me something like really complex? I do that to you all the time.
Yeah. And obviously, I'm not the person to be showing off the complex things. So that's a great question. It's funny. It strikes me that a lot of the stuff we do, which to us seems really straightforward, is actually complex in comparison to what kinds of tools marketers can typically get off the shelf or have access to. So I think our attribution analysis continues to get more complex, especially as we refine the process of bringing in multiple data sets and making it a more advanced model for online and offline channels. So I think that that's definitely something. Um, I know that natural language processing is definitely moving right along in terms of its ability to write full bodies of content. And so that I would say is probably an advanced use case. It doesn't sound like it, but the methodology to get from A to B to train the model on how you want things written is probably more work than somebody might realize. So I think those are the two that stick out to me. And obviously, you know, um, you know, um, doing analysis on large quantities of data, something that would take someone a very long time to do is something that, Chris, you've figured out how to streamline down to mere minutes or hours, depending on how large the data set is.
It's interesting when I think about that question. There's actually a slide that's in my Macon talk. It looks like this. And this is a sheet of paper and two different ways to put a hole in that sheet of paper. One is clearly not the right choice, right? And the other is, the normal sensible choice. And I bring this up because I think it's an interesting question, but I also think that there's a lot to be said for knowing what level of complexity you actually need. Not just, I'll be the first to raise my hand and say, like, I love messing around with cool stuff and fun stuff and things, right? But I don't, for a lot of use cases, it's overkill, right? Like, do
Mhm.
you need a neural network to do basic sentiment analysis? Not really. When we look at something like analyzing Twitter bios, do you need a sophisticated neural network to do that? No, no, you just count in words. Right? It's not super complex. So I think one of the challenges that we run into, and I know other people run into, is especially with vendors, getting getting a solution that is just overkill or not a good fit or made needlessly complex, I guess is a good way of putting it. It's just you're just trying too hard.
Well, it's funny. We literally maybe 30 minutes ago had this exact conversation about the approach to analyzing some data. So, on behalf of one of our clients, we're putting together a feedback survey. And as the survey has evolved, the set of questions has become shorter and more focused. So when we originally put it together, we imagined, 40, 50 questions, and we would have to write code in order to analyze a lot of text to pull out themes and, sentiment, common words, those types of things. And now, as we're getting closer to finishing the survey and launching it, we're realizing that, well, if it's only about 15 questions and we're only going to have 5 to 10 respondents on this thing, we probably don't need any code at all. We just need a well organized Excel spreadsheet that we can look at and pull out data points. And so you're absolutely right, Chris. I think understanding the purpose, the question that you're answering, can help you determine how complex a solution you need. And I think that, I mean, we've been talking about this, 6 ways to Sunday, solutions in search of problems and complex AI and, this, that, and the other. And so it all boils down to the same thing, of what's the question you're trying to answer.
It does. And when you're working with AI technologies in particular, one of the things you have to keep in mind is compute cost, right? The
Hmm.
more complex you get, the greater the computational burden. There are some things, when I look at the attribution analysis we do, if we were to choose a more complex algorithm, would what is typically like a 5 to 7 minute process could be a 5 to 7 hour process, which is fine if it's just you. But if you've got 10 clients, suddenly talking 50 to 70 hours of compute time versus an hour of compute time. And I think when we're doing requirements gathering, I don't think that's taken into account enough, is to say we have to balance the outcome with
Hmm.
the computational cost, the expense. I was trying to put something together this morning in Watson Studio. And it's like, this operation will cost you 20 hours of compute time. Like, cancel. Stop. Don't do that. Like, I don't know what it was that it was saying. Like, this is a really expensive operation. But
Right.
it got me thinking, like, that's overkill.
Well, and it goes back to sort of, getting those business requirements and playing out those scenarios. So, a lot of times we talk about scenario planning in terms of what happens if you don't do the thing versus what happens if you do the thing. In this instance, the scenarios that you're really describing, Chris, are, what if I want the Toyota Tercel? Is that going to get me from A to B? Yeah, absolutely. What if I want the, Nissan? Will that get me to A to B? Yep. What if I want the, whatever the latest Tesla is? Will that get me from A to B? Absolutely. They all get you from A to B. It's just a matter of how much you're willing to invest and how fast you want to get there. And so thinking about it in that context, you might say, so Chris, you said, okay, 20 hours of compute time. I don't need that. So maybe the Toyota Tercel is good enough to get you from A to B, and you can continue to, change the tires and make sure that your engine fluid is, always fresh or whatever cars do. I don't know. I'm not a mechanic. This is probably a terrible example. So, but make sure your brakes are working correctly. Maybe you spring for an automatic car starter to make it a little bit more like up to date. So there's things that you can do to build on over time instead of starting with the Tesla.
Yeah. And now going back to Ashley's question about what are some of the more sophisticated things, there are some things where the models, being the pieces of software being used, do have to have a certain level of sophistication. Like if you're doing natural language generation, there isn't a cheaper, easier shortcut for a lot of that stuff. There really is. You've got to use the big, heavy uh, compute power because it has the highest level of accuracy. So I guess that's your third trade-off: is you have your requirements, you have the
Hmm.
computational costs, and then you have the quality of the outcome.
Hmm.
And you got to just kind of push and pull and say, okay, well, if we really want the quality outcome to be high, it's going to push the compute price up, and it's going to make the business requirements a lot more challenging because you have to be very, very clear about what it is that you want this thing to do. LinkedIn discovered that when they started building with deep learning models for their analysis of what members were posting. Like, yeah, you need to invest a lot of money and a lot of compute time to make this work. But when you look at those outcomes, you're like, wow, those are really, really good outcomes. Like when these language models start writing like entire press releases all by themselves, you're like, wow, that's slightly alarming.
So, what's interesting, Chris, is what you're describing is the three constraints of project management. This is a very old theory. And so, basically, your quality is determined by your time, your scope, and your budget. And it's not that you can't have all three, but each of those balances out in terms of the quality of the output. So if you want it, I think you have a different version of this in your talks. Like if you want it fast and cheap, then you can't have this. Or if you want
Good.
it
Yeah.
like, so it's along those lines. So that's essentially what you're describing is of these three things, you can pick two. So which of these two things do you want? Do you want it fast and cheap? Do you want it expensive and high quality? Like what is the most important to you in terms of the output?
Right, yeah, it's fast, cheap, good, and the unless you're Google, I mean, even those constraints still apply to Google. You you really can get a situation where you can have all 3, right? You have to trade something off somewhere,
Right.
and I think a lot of folks are under the impression that AI and all these technologies somehow nullify that trade off. Like, yes, you can have your cake and eat it too. Well, no, you can't.
So what is it about AI? And this might be a rat hole question, but what is it about AI that people think is going to suddenly, solve all of those problems? Is it because I think about this when I hear these questions come up, and maybe I'm asking the wrong question. This is me, my brain processing information live on the podcast. Um, so as a CMO, I want to introduce AI in order to cut down the time it takes to write content, for example. So I introduce AI, natural language processing, and it writes content. Well, guess what? Someone still has to edit that content. Someone still has to post that content. Someone still has to tell the AI what to write about. So there's still a planning aspect of it. So did the AI save you any time? Or is it more of a headache to get everything set up and working the way that you want it to? And it's never perfect.
I think it's 3 things. It's understanding culture and expectations. So understanding is the first thing. People don't understand the technology. They don't understand what it can and can't do. They
Hmm.
kind of assume it's magic. Um, and therefore, because they don't understand the underpinnings of it, they don't know what its limitations are. Secondly, is cultural. Everything from Wall-E and Short Circuit to Terminator movies and things have created this perception that machines are A, infallible, and B, are much more capable than they actually are. And third, and I think this is where we see the problem in business, is level of expectations. Everyone who asks questions like that is looking for a shortcut. They're looking
Yes.
for disproportionate returns on their investment. It's the same thing we see in public relations. When that was sort of the pitch of a PR firm, was you could get disproportionate results for the dollars you invest. We would always say in pitches, advertising is linear. You put a dollar in, you get this, right? And you put another dollar in, you get this plus this. And it scales. So you keep putting more dollars in and you keep getting this, mission curve. And the promise of PR, which almost never worked out, um, was that you put a dollar in, you get $10 out, right? You get this big story in the Wall Street Journal, and suddenly the world would beat a path to your door. And that was the promise that PR folks would pitch for years. And I think the
Hmm.
AI thing does the same thing. It's like, hey, if you use this machine, you're going to see disproportionate results, like winning the lottery. Magic will happen, and everything will be better. Certainly, that's what the vendors say.
Hmm. Well, so, that brings up a different aspect of AI is it's only as good as the data that you feed it. And so if you knew how to pick the winning lottery numbers every single time, you wouldn't need AI. So feeding losing lottery numbers into an AI isn't going to suddenly predict winning lottery numbers. And so if we keep going with this example of writing content, that was you said sort of what I was thinking was, are people just looking for shortcuts because they don't want to write content or and so if you don't want to write content, then the content that you're currently creating is probably not great. So you put your content into this AI to write your content for you. Guess what? You're still going to have not great content because the AI can only write what you give it.
So that's where I think there is some potential for slightly disproportionate results. Because if you hate writing content and you're bad at it, you just crank out crap, and you
Right.
use a naive pre-trained model like GPT-J, for example, and you have it right, it's going to create mediocre content. It's not going to create crap like you face rolling against your keyboard. It's going to create garbage. It will create, like a white bread and mayo sandwich. No one, you won't starve to death, but no one's asking for that at Chez Panisse.
I like those, by the way. So I would ask for that.
Artisanal mayonnaise.
Oh, I'm sorry. The artisanal one feels.
Uh, but if your content's crap and the AI content is mediocre, that's already an improvement, right? It's an
Hmm.
improvement over the garbage you're putting out. And in all honesty, when you get a lot of the marketing communications we get from other companies, it is garbage. So AI producing mediocre would actually be a disproportionate return on your investment because you're no longer handing out pure garbage. Now, is that good enough to stand out? No. Is it good enough? It's like AI creating music. I used um, the Ava tool for creating the music for the pre-roll for the talk I did with Kathy. I use AI for its intended purpose. Was it great music? Mm-mm. Is it going to win a Grammy? No. Is it good enough for like a one-time broadcast? Sure. It was inoffensive.
Well, and I guess that's sort of back to where we started was, if you think about the different use cases or the different versions, how complex to how simple, I think it's always probably a good option to start with, is it good enough? Are you going to get good enough data to do something with? Because you can always improve upon it. I think the trap that a lot of us fall into, and we've been guilty of it, so we're not pointing fingers, is we try to perfect something. So we spend much more time, much more energy, much more budget and resources trying to perfect something before just, okay, now we just need to start using it. And I think the same is true of AI. We try to make it perfect and do exactly every little bit and piece that we want it to do. It needs to write our content and fold our laundry and make our coffee and balance our checkbook and hire people. Like, you could maybe just start with one of those things.
Exactly. And the other thing that computation I think is very interesting, and I forget where I heard this, is that AI is bad at what we're good at, and AI is good at what we're bad at. Machine tasks like computer vision, natural language processing and stuff are very intense, compute intensive processes that are very difficult for machines to learn. On the other hand, doing something like logistic regression, super easy and fast for a machine, but you and I are like, I can't do that by hand. I mean, it's been a while.
Yeah,
um, you look at the formula for logistic regression, you're like, what goes where? But the machine's like, okay, cool. You need a million record data set, logistic regression across it here, done. And
right.
so from to Ashley's question about what are the higher level applications, in some ways you may not actually need them for some of the things you're trying to do. And to your point, there may be some easy wins in the tasks that we're not good at that the machines could crunch instantly and to save us a whole bunch of time.
So what strikes me is one of the misunderstandings of how AI works. I think there's this, idea that AI produces things instantly, and that's where the time savings is going to happen. Like, I press a button and the AI automatically shoots something out at you and you have the thing. And what you're describing, Chris, is, you know, 5, 10, 20 hours of computation time. And so, is it machine learning? Yes, it absolutely is. But it's just running in the background. It's not doing anything exciting or interesting. You're just watching your terminal screen just like churn through line after line after line. But that's what it is. That's how it works. And it's not, depending on what it is, it may not be faster. It may be faster than someone trying to hand compute all of that stuff, but it still takes time to run all of that information through to create what may be a single line output. And I think that that's a misunderstanding in terms of how it works, but also when you factor in the complexity. And so obviously the more data that you have, the more things you want it to do, go down the list, the longer the AI is going to take to give you back a result. It could be 3 days.
It's interesting you say that too because I think the the AI and machine learning community have not done a real good job of explaining like the difference between data science and AI. And I think that distinction is important for marketers because many times you're probably asking for something that's the wrong thing. So the
Mhm.
fundamental output of data science is an answer. I have a question, here's an answer. The fundamental output of AI is a piece of software. Hey, I need a machine to do this thing. The machine creates its own software. If you're looking for an answer, you're not looking for AI, you're looking for data science. You're looking for like what channels worked best. You may use machine learning techniques, like Markov chains for or for example, but
Mhm.
fundamentally, you're not getting a piece of software you put into production. You're getting an answer to your question, like, "Oh, let's spend less money on Facebook." Um, Whereas if you are looking for a piece of software to do the thing a lot, then
Mhm.
you're looking for AI, and I think that distinction is kinda lost on people.
I would agree with that. I've heard, machine learning, data science, AI, all of those things used interchangeably. And I know when we talk about artificial intelligence, we talk about the hierarchy of statistics, machine learning, deep learning, those things, and how they all are different layers of artificial intelligence. And so you might just be doing statistics. You might just be using a piece of code to run a linear regression model. Is that machine learning? Yes. Is it artificial intelligence? Yeah, sort of, not really. You're really just expediting the mathematical equation. You know,
Right.
it's not giving you any information outside of what you've asked it to do. It's not learning anything. It's literally just computing quickly. And so I
And
think you're
that might
absolutely,
be okay.
and that might be okay. It's funny. I look at this image. If you're listening to us, then you can see the image up on our YouTube channel for this, and we can post this image along with our social posts of this podcast. But basically, what I see is the Chris Penn tool and the Katie Robert tool. So if you asked, and I mean that lightheartedly, like if you ask both of us to make a hole in a piece of paper, I'm going to grab the hole punch and Chris is going to grab the power tool. And I think that it speaks volumes to our approach of how to solve the same problem. And that's, something that you can look at within your own organization, with your own teams. If you ask everybody the same question, how do they approach solving the problem? And that will give you a good understanding of, how complex the solution might need to be.
Yep. And yeah, and one of the things that I think really reemphasizes that is we've seen it in Google's handbook for developers around machine learning. The first rule in their machine learning handbook is if you don't have to use machine learning, don't use it because it's incredibly compute expensive. And for that to be the first rule in the machine learning handbook is like, oh, that's interesting. Instead of the answer you'd expect is make everything a machine learning problem. Solve everything with machine learning.
Do you think that people try to use machine learning just to say that they're using it to sound advanced, to, give this perception of things that aren't actually true?
Uh-huh. Without a doubt. In 2018, the Financial Times investigated 100 companies that said they use machine learning, and 35 of them were lying. Just not a scrap of machine learning anywhere. They were lying just for marketing purposes to say that they were trendy. They were one of the cool kids too. Um, and that's very much the case where because there's this perception. And we're going back to our three factors
Hmm.
that machine learning can give you disproportionate returns.
Hmm.
It then, in vendors' mind, says that we can charge more for this. Right? Oh, if we're using machine learning, I can add a zero to the price tag. And then on the other side of the table, the CMO is saying, "Oh, they're using machine learning. I'll get 10x better results out of this."
Hmm.
So it justifies the increased price tag. And the realists are all saying, "All of you are lying to yourselves and each other."
I find that psychology really fascinating. I can understand it from the wanting to, create this perceived value of if you're using AI, then it must be better. Um, but the realist in me is like, well, who cares how it gets done as long as the results are good? Like, you should be signing up for the tool that gives you the best results based on what your needs are, regardless of whether or not they use AI or not. And I get that that's a very, difficult thing for people to stand behind because there's a lot of pressure to be doing the latest and greatest and staying ahead. But quite honestly, sometimes the latest technology isn't going to give you the answer that you need.
Or it's going to give you it in a way that's not sensible. We ran into this 2 weeks ago when I was cleaning up our Instagram influencer list. I had a list of 14,000 Instagram accounts. And I have the URLs of those accounts. And so my choices were, could I write a scraper and an image recognition algorithm that do facial detection? Like, is there a face in this image? Yes or no? And I figured it was going to take me about 80 hours of work to code this thing to make it run. Um, or could set up a process on Amazon Mechanical Turk, make a bounty of 1 penny for every account you verified. So you click on the link, go to the Instagram profile, and then go back to Turk and say, is there a picture of a human in this profile? Yes or no. It was done in an hour and a half from the time I launched it, and it cost $230 to screen all 14,000 accounts. The error rate was about 1%. The machine error rate on the first time around is going to be around 75% rate. So 25 to 30% wrong is the error rate. So I had this choice of using artificial intelligence, which would have cost 80 hours of time, no dollars, but 80 hours of time, and a 30% error rate, or using human intelligence, or a couple $100, but a 1% error rate, and done in an hour and a half instead of 80 hours. Just because there's an AI solution didn't mean it was the right choice in that example. It was the wrong choice.
Yeah. I think that's hard for people to come to that conclusion. Because a lot of it is you don't know what you don't know. And so they'll reach for the AI solution because they don't know what the other option is. They don't know how to solve the problem themselves otherwise. They may not know that something like a Mechanical Turk exists to solve this problem. So I think that a lot of it is around just education. And so, that Google developer handbook saying, if you don't need to use machine learning, don't. I think it's a good place to start. But what it doesn't do is, and it's not their job to do it, but what it doesn't do is educate, like, here's the other things you could be doing instead.
Exactly. Here's all the different options. And you're right. A lot of people may not know that tools like Mechanical Turk and Upwork and all these places exist that can use human intelligence, which is still, for the most part,
I
the
can see how
preferred form.
painful it is for you to say this.
It is because, I look at some of the things people say in the news and like, wow, how did we ever survive as a species with people that dumb? But that's for another show.
Yeah, probably not this show. Um,
So, but I think though that raises an interesting point, to round out to Ashley's question about what are the most sophisticated forms of AI. I actually think at the both the bottom and the top of the pyramid is human intelligence to be able to say, like, yeah, there's a bunch of things machines are good at. There's a whole bunch of
Mhm.
things machines are bad at, and the really sophisticated marketer knows when to use which.
I would agree with that because I think, once again, all the AI in the world is great, but at the end of the day, a human still needs to create it, build it, maintain it.
Exactly. It's no different than your blender. It's just not as tasty when it's done.
And on that note,
And on that note, if you've got comments or questions about anything in today's episode, please hop on over to our free Slack group. Go to trustinsights.ai/analytics for marketers, where you and over 1,900 other folks can talk about analytics, data science, your marketing challenge of the week, or AI to your heart's content. And wherever it is that you're watching or listening to today's show, if there's a channel you prefer it to be on, go to trustinsights.ai/TI podcast, where you can see all the other options. Thanks for tuning in, and we'll talk to you next time. Need help making your marketing platforms, processes, and people work smarter? Visit trustinsights.ai today and learn how we can help you deliver more impact.